Most space missions investigate the surface or atmosphere of a body. But NASA's InSight probe, which landed on Mars in November 2018, is different. It is the first mission dedicated to studying the interior structure of the planet and whether it gives rise to Marsquakes. Now the results from its first 10 months on the Martian surface have been published in a series of papers in Nature Geoscience and Nature Communications. See an overview here. Artist's impression of InSight on the Martian surface. The seismometer is under the white dome to the left of the landing platform. NASA/Caltech InSight touched down via parachute and retrorockets on the plains known as Elysium Planitia, lying between the ancient volcano Elysium Mons and Gale Crater, where the Curiosity rover is exploring. Although it is still trying to find a way to hammer its heat probe adequately into the ground, other aspects of InSight's surface activities have worked well. We call it Discotechniz, our full-blown tech festival disguised as a conference. Let us boogie read. Strange signals coming from space every 16 days are puzzling scientists. For example, it successfully managed the crucial operation of using a robot arm to place a seismometer, a very sensitive vibration detector, on the ground well clear of the landing platform, and then to cover it with wind and thermal shield. This was to isolate it from vibrations caused by wind or lander itself, and that could otherwise drown out any vibrations caused by quakes. Seen from InSight's fishy camera, its seismometer undisturbed on the Martian surface under its dome-like windshield, while nearby the robotic arm adjusts the digging instrument. NASA/Caltech. Up to 30 September 2019, 174 seismic events had been recorded. None was stronger than magnitude 4 on the Richter scale, which is commonly used to measure earthquake sizes on our own planet. There were 24 whose magnitude was in the range 3-4, meaning the energy released would be similar to exploding about a ton of CNT. It might sound a lot, but would pose very little risk for future astronauts on Mars unless they were unfortunate enough to be very close to the epicenter of a quake. The sound of the first detected Marsquake, 7 April 2019, speeded up 60 times. In this extract, there is first noise from the local wind, then the seismic event itself, and the spacecraft's robotic arm as it moves to take pictures. Unlike the Earth, the outer layer of Mars is not broken into moving tectonic plates. It has therefore been suggested that vibrations caused by meteorites hitting the surface may be to blame for any Marsquakes. But so far as can be told, the quakes were all generated inside the planet itself. Though less strong than the biggest earthquakes that would be detected on Earth during any 10-month period, these Marsquakes are a lot stronger than the moonquakes recorded by Apollo seismometers. And whereas moonquakes appear to result from the slow contraction of the moon, the situation appears different on Mars. Locating the sources and the best determined events, it was possible to distinguish two kinds of vibrations. First, the compressional. You can read full post on Cryptophans News, link available in text below.